In this video, we'll look at what it means to divide terms with exponents, also called the quotient rule. Before we begin, let's revisit how dividing works. If we look at that first problem, you could grab your calculator, but you could also work smarter, not harder. If I look at the numerator and denominator, I see a couple things that cancel. A 5 on top cancels out with a 5 on the bottom because that's equal to 1. So the 5s would cancel to 1, the 6 would cancel to 1, the 2, the pair of 17, the pair of 31, and a pair of 4s, leaving that all equal to just 4. Now variables cancel out in the same way that numbers do. M divided by M would be like 5 divided by 5. It would equal 1. So these M's would cancel, this pair would cancel, and then the pairs of Y would cancel. So all of that would be equal to M times M, or since we're talking exponents, M squared. So here we're going to look at what happens when you divide an exponent by another exponent with that same base. So if we do 2 to the 5th divided by 2 squared, we can actually do that on our calculator and see what that's equal to. Again, I always recommend parentheses. So parentheses 2 caret 5 divided by parentheses 2 caret 2. And I see that I get an answer of 8. Let's look at why it's equal to 8. Expanded form, of course, 2 to the 5th would be 2 times 2 times 2 times 2, a total of 5 times, whereas 2 squared would be 2 times 2 just twice. Revisiting those last examples, I know that a 2 on top would cancel with a 2 on the bottom, so these would equal 1 and these would equal 1. If I look at what's left, I have 2 times 2 times 2. That's 2 times itself, a total of 3 times. 2 to the 3rd power is equal to, you guessed it, 8. Let's look at one more example using variables. X to the 7th, x times x times x times x times x times x times x. X squared would just be 2 of those. Thank goodness. If I look at what cancels, 1 from the top and 1 from the bottom, 1 from the top and 1 from the bottom, leaving me with a total of this many x's, which happens to be 5. So x to the 7th divided by x squared, those 2 from the bottom are canceling out with 2 from the top, leaving me with x to the 5th. Do you notice any shortcuts in these two examples? So dividing exponents by exponents, or the quotient rule, if we think about this example, it's slightly different from the last one. X to the 8th divided by x squared. We've talked about how numerators and denominators are canceling out. So the 2 x's on the bottom are taking away 2 from the top, which leaves us with x to the 6th power as our final simplified form. What's happening here is, you've guessed it, we keep the base, and we subtract the exponents. Again, that denominator is taking away from the numerator. Shorthand way of saying that, a to the m over a to the n would be equal to keeping the base of a, subtracting the exponents m minus n. So let's look at some examples. 12 to the 10th divided by 12 to the 5th. So this would really be 10 12s over 5 12s. So I would still have 12s left over. You cannot cancel the bases. So I'd keep the base of 12 and subtract 10 minus 5, leaving me with 12 to the 5th power. AKA, I would have 5 12s left in my numerator. Variables work the same way. Keep the base of m, subtract my exponents to give me -3. Again, more on negatives later. I think it's more obvious to not cancel out your bases when you have a variable, so remind yourself of that even if your base is a number. Keep the base always. If we look at this next one, we have some things with exponents, but we also have coefficients. Similar to when we were multiplying these or taking them to powers, we can split this up. So I can think of this as 15 divided by 5, and then x to the 9th divided by x to the 3rd. These are normal numbers. I would divide as my problem says. So 15 divided by 5 gives me 3. These are not normal. They're exponents. So I have to use exponent rules. Dividing exponents is the same as taking away, so I would subtract, keeping my base of x, 9 minus 3 to give me a final exponent of to the 6th power. Summary, if they're normal numbers and do not have exponents, do as the problem says. If they do have exponents, use exponent rules. Let's look at some more intense examples to close it out. A to the 3rd times b to the 8th divided by a times b to the 4th. This is 1a, so it's taking away 1 from the top, leaving me with a squared. And then the bottom 4 b's are taking away from the 8, leaving me with only 4 left over. If we look at the next example, we have coefficients. I'm going to kind of divide these up visually so I can treat it as 3 separate problems. The 20 and 5 do not have exponents. I'm not going to use exponent rules. Instead, I'm going to actually divide them. So 20 divided by 5 gives me 4. The next sets are exponents, so I need to use my exponent rules. So x to the 9 minus 7 and y to the 6 minus 3. That would give me x squared still left and y to the 3rd still left. Same thing with this last example. I'm going to kind of visually split that up for myself. 2 divided by 4 is a decimal or a fraction. And then we have x to the 5th, x to the 7th, so 5 minus 7 for my x's, leaving me with x to the negative 2. And then y to the 12th minus 11, which would be y to the 1st. There are many different ways to write these that we'll explore here in the next couple of videos. For now, feel free to leave them like that.